Welcome to video lecture number 2, Groups, Periods, and Reactivity. In the last video, we talked about the basic arrangement of the periodic table and a little bit about the group numbers, but not about their significance. In this video, we'll discuss what the group and period numbers actually mean and how they relate to reactivity. Because we're talking about reactivity, you know we're going to talk about valence electrons. Go ahead and pause the video and record the essential question in your notes. So first we need to talk about a few words. I've seen more missed test questions because of these words getting mixed up than I care to relate to you. Groups are the vertical columns of the elements on the periodic table. Vertical means up and down. In algebra, you'll study parabolas later this year, and you'll often draw a vertical line through the vertex or tip of a parabola, which is this shape. You'll often hear a group referred to as a vertical column, and that might help you remember what vertical means. A column is simply something that goes up and down. Think of columns or pillars that hold up the roofs of buildings like the White House or these old Greek pieces of architecture. If you hear the term vertical column, you should be thinking of groups if we're talking about the periodic table. Periods are the horizontal rows on the periodic table. You can remember that horizontal means from side to side because a sunset happens on the horizon. Whenever someone mentions rows, I think of gardens. That's because every Saturday my family works on the rows of flowers and vegetables in our garden that grow from side to side. So if you hear the term horizontal row when we're talking about the periodic table, you should be thinking periods. One other way that I remember that a period goes from side to side is you write from side to side and you end your sentence with a period. All right, now that we've discussed the vertical columns being groups and the horizontal rows being periods, let's talk about their significance, the exciting part. We've already talked about group numbers a little bit. They're found at the top of the periodic table, and in this class we skip the dip, so we're using group numbers with A's only. The period numbers are here on the left side of the table. So what do the group and period numbers mean? We've looked at some patterns in class and determined that each new period represents the repetition of a pattern. Let's look at the group numbers for the main group elements. We start with hydrogen in group 1A. The first period only has 2 elements, which is kind of odd, and helium is all the way over here in group 8A. That's the end of period 1. So the pattern begins again with lithium in group 1A, then beryllium in 2A, skip the dip, boron in 3A, carbon in 4A, nitrogen in 5A, oxygen in 6A, fluorine in group 7A, and neon in group 8A. That's the end of period 2. Period 2 has 8 elements, or 8 group numbers, and so does group 3. The pattern begins again in period 3 with sodium in group 1A, then magnesium in group 2A, then aluminum in group 3A, silicon in 4A, phosphorus in 5A, sulfur in 6A, fluorine in 7A, and argon in 8A. That's the end of period 3, and we have to start a new period. Each time we move across all 8 groups of the main group elements, a pattern is repeating itself. So what gives? Why 8? What else have we studied that relates to the number 8? Remember the octet rule? Take a look at this. It's a modified periodic table. The transition metals have been removed completely, pushing boron and aluminum to the left until they touch beryllium and magnesium. And instead of chemical symbols, an atom of each element is modeled. Look at the electron clouds of the atoms. Do you see it? Hydrogen has 1 valence electron. So does lithium and sodium and potassium. They're all in group 1A. Beryllium has 2 valence electrons. So does magnesium and calcium. They all happen to be in group 2A. Boron and aluminum have 3 valence electrons, and they're in group 3A. And the pattern continues with carbon's group, oxygen's group, and fluorine's group. They all have the same number of valence electrons as their group number. The group numbers, at least for the main group elements, are the number of valence electrons for all the elements in that group, or vertical column. But wait, I know what you're thinking. You guys are fast to find exceptions. What about helium? It's in group 8A, and it only has 2 valence electrons. What gives? Well, that's a nice segue into period numbers. Remember how the first energy level in the electron cloud of an atom can only hold 2 electrons? Helium has a full outer shell of valence electrons because it only has 1 shell, or 1 energy level. Notice anything about the elements below it? Neon and argon? That's right. They also have full outer shells of valence electrons, except they have 2 or 3 energy levels, which can each hold 8 electrons. That's the pattern. As you move across the periodic table, you add a valence electron at every group number. When you get to the end, group 8A, that energy level is full. So the electrons have to go to a higher energy level. The period numbers on the left represent how many energy levels an atom of that element has. That has some implications for describing reactivity with the periodic table, not the least of which is the fact that all these guys, the elements in group 8A, have full valence shells, making them inert. That's why helium is here, even though it only has 2 valence electrons. The elements in group 8A, they happen to be called the noble gases, we'll talk about that later on, are non-reactive. So let's go back to the real periodic table. Just by its placement on the table, you can say a lot about an atom of an element. Take bromine, for example. It's here in group 7A. That means it's got 7 valence electrons, making it very reactive. And it's got the same reactivity as all the other elements in that group. It's also in period 4, so we can say an atom of bromine will have 4 energy levels and 7 valence electrons. Magnesium, over here, has 2 valence electrons, since it's in group 2A, and 3 energy levels because it's in period 3. All of the elements in the same group number, because they have the same number of valence electrons, have similar chemical properties.